So good morning, everyone, or good afternoon, wherever you are. So my name is Prashant Kumar, and welcome to the webinar number 31 for the Reclaim Network Conf Plus. So today we are having this webinar in collaboration with the University Global Partnership Network. So there is a project funded through the network. I will just explain a little bit more in detail on the similar topic, and that is in collaboration with the North Carolina State University and University of Sao Paulo. So this is the team of the network, where we got the colleagues coming from 5 different institutions, including the UKCH, Bangor University, Warwick, and University of Bath. And we got our the network manager and Mark Simmons and Charlotte Lidan, who is helping with the thing. The network is funded by the UKRI, so there are 3 councils: EPSRC, NERC, and AHRC. So as you can understand, it's a very multidisciplinary network looking into implementing the green-blue infrastructure in cities. So usually these webinars happens every first Wednesday of every month, which is between 12:30 to 13:30, and each webinar has got 2 speakers, and each of the speakers has like 20 minutes each, and then we take the questions and answers in the end. All these recordings are available on our YouTube channel, so we'll post the link to view them. So as you can see, that the whole idea there has been to bring in the mix of speakers from nationally and internationally, from academic and non-academic background. Like you could see the previous one coming from 2 very different areas, talking about the urban park and improving access to the parks, especially for the women and girls. So the network has loads of activities, including the reviews, secondments, webinars, and all. We have around 642 members as we speak, and that includes basically they're coming from different areas, as you can see, from government sector and academic sector, and and they're having the wide interest in terms of the air pollution, physical health and well-being, and so on. So just to finish with, we have a upcoming conference on 30th of January. That conference, we are inviting everybody to come and join. So that's going to be at the University of Surrey. So this will be a fascinating opportunity to meet in person and possibly have more interactions there. So just to introduce very quickly, this UGPN project, which is collaborating with this webinar this month. So this project is called UGPN NBS, which is the developing a network on prescription of nature-based solutions to cities. So that led by me with my colleagues from University of Sao Paulo, Professor Maria Di Fatima Andrade, and the lead from the NCSU side is Dr. Rajan, who will also be taking the Q&A session for this webinar. So the whole idea has been to focus on the nature-based solutions and bringing in different methods and techniques to look for their implementation for making the cities resilient. So you can find more about the project online, where we have the information. So today we got 2 fantastic speakers. And our first speaker is Dr. Madhusudan Katti from the North Carolina State University. And he's the Director of Science, Technology, and Society and Associate Professor in the Department of Forestry and Environmental Resources at North Carolina State University. He's also the Editor-in-Chief of the Bulletin of the Ecological Society of America. His work centers reconciliation ecology, the human, the application of evolutionary ecology to find real-world solutions for reconciling biodiversity conservation with human well-being. As an ecologist by training, he engages local communities and broader public in studying how human activities and histories of colonization and segregation shape the distribution of nature and biodiversity, especially in urban areas, in the context of global climate change. So without any further ado, I'm going to pass on to Dr. Katti. But before that, I'd like to make a couple of housekeeping notes. So these webinars are recorded, so you can see them later on our YouTube channel. there is a Q&A box, so we would encourage you to write your questions and answers in that box and write your name and affiliation if you want it to be read with your question. And this Q&A session will be chaired by Dr. Rajan Parajuli, and he will read your questions to the speakers. So the Q&A will happen after both these talks have finished. So I think yes, please, Dr. Katti, please share your presentation, and the floor is all yours now.
Thank you, Dr. Kumar. Thank you for your invitation to speak in this webinar. Let me share my screen so you can see my slides. Is that working for everyone? Okay. So what I want to talk about today is some work we've been doing in Durham, which is a city in this research triangle region, not far from Raleigh, where my university is located, where we've been looking at how social inequality and the legacy of systemic racism are influencing current sort of patterns of biodiversity and urban forest cover. So I want to start by reminding people that cities are deeply unequal and unjust places, both for people and for nature. You can see these images from this really remarkable website called unequalscenes.com. The top one is from Mumbai, my hometown. The bottom one is from Cape Town, and there's a series of images, aerial images that show the stark contrast in highlighting inequalities in different parts of the world. We know that cities are places with extreme gradients in socioeconomic inequalities. They also have histories of segregation among people, which might be racial, it might be along lines of religion or caste or ethnicity and other ways that people segregate themselves. And it turns out that biodiversity patterns in cities reflect these gradients. For example, there's a well-known correlation between wealth and number of species of birds, plants, insects, mammals, and so on in cities around the world. And likewise, urban forests, for example, or other kinds of green infrastructure also tend to reflect these underlying inequalities. But what I want to argue is that it doesn't have to be this way, and we can actually be proactive in addressing the effects of these kinds of inequalities in the past. Cities are complex social ecological systems. Right? This is a diagram from a remarkable paper by Christopher Scheller and colleagues in 2020, where they, for the first time, sort of really held the mirror up to urban ecology community and pointed out that a lot of what we see in cities is in terms of ecology and evolution, which is what a lot of my colleagues are focusing on, are actually driven by underlying patterns that include systemic biases in the way cities are structured. So we tend to focus on this gray box and trying to understand what's happening in nature, but a lot of what's happening in this gray box is driven by this interactions that are much more deep rooted and that shape how cities form and function. And in this way, both environmental and social justice are deeply linked, especially when you're working in cities. So cities are dynamic. And as I said, you see forms of geographic segregation in cities for people, which then also reflects in nature and biodiversity. So understanding the underlying social geography of people in cities is crucial to understanding the biogeography of cities. And social inequality and systemic racism are key drivers of urban social ecological systems. And I'm going to be using this diagram as a sort of map for my talk as well. So I want to give you a quick background on this policy that existed in the US from the 1930s to 1960s called redlining. This is a policy developed by a federal government agency called the Homeowners Loan Corporation, which was charged with basically providing means for people to become homeowners, because homeownership is a primary means of wealth in the US, part of the American dream, so to speak. But the way they carved out different parts of the city into different zones of, of different degrees of desirability for where people want to live. And often these zones that are classified from A to D were drawn using racial and ethnicity indicators, as well as environmental and other indicators. And this set the template for how loans were given to people of different ethnicities, where people were forced to live or where they were unable to afford to live. And these kinds of things essentially reinforced previously existing patterns of forced segregation, among Black and white people in the US. And this also translated into discriminatory lending policies. Banks would discriminate, and that practice still continues covertly with some major banks in the US. This policy was outlawed in 1968 with the Fair Housing Act. However, the fact is that it was in existence for a long time, and its effects continue to reverberate even now. Redlining was not something that was applied to every city, but it was definitely applied to more than 200 cities in the US. So a huge impact in terms of structuring cities around the country. And a quick look at how these different A, B, C, D zones are described, just from this paper by Nelson and Vining, looking just a textual analysis, and you can see that the A and B zones have less pavement, have fewer odors, as they're, these words come up in the descriptions of A versus D zones. So D zones have higher levels of odors, more surface, more manufacturing, more mills, more factories. So the more industrial areas tend to be C or D zones. The less industrialized areas tend to be A or B zones. Likewise, A or B zones tend to have these more favorable environmental descriptors like wooded, shade, golf, or trees, right? So you can see sort of the template being set here for environmental gradients based on this policy. And it turns out that even now, there are significant markers of social vulnerability, including health parameters that differ depending on where you live according to this redlining zones. So the higher ranked A or B zones have a higher life expectancy, largely white populations, low poverty, and lower levels of these various health issues that are typical in urban areas. Whereas C or D zones, this is in the city of Richmond in Virginia, C or D zones have a lower life expectancy, significantly lower, much more of a minority population, high levels of poverty. So you can see how a government policy sort of reinforce segregation and inequality here. In recent years, since the Shell et al. Paper that I mentioned earlier, there have been a number of studies that have looked at the consequences of redlining in cities around the US. So this is just a quick summary to show the different studies. So there's a number of studies have found that there's significant differences in tree canopy cover, in the amount of impervious surface in cities, in noise pollution, as well as in land surface temperature and air pollution. In each case, the A zones, the green line places, are much healthier versus the D zones that have much less of these environmental amenities or green infrastructure, if you will. That also has consequences for biodiversity. I study birds primarily in my career, and this is a study from Los Angeles, came out a few months ago, where they found significant differences in bird species diversity between A and B zones versus C and D zones. So these differences get reflected in bird diversity as well. What I'm going to share now are results from a PhD work done by my student, Dr. Jin Bai, who finished just a few months ago and is currently a postdoc at Duke University. And his work, what I'm going to share now, is focused on a few questions that we're looking at the legacy effects of redlining that are still persistent in Durham right now. So one question is, does past redlining in Durham affect the current green infrastructure? By that, we specifically look at tree canopy cover, impervious surface cover, and urban heat island effects. And also, does redlining continue to have effects on bird diversity in city parks specifically. So let's look at tree canopy cover. This is a map of Durham that shows the red and green line zones overlaid with tree canopy cover. Right. This is this layer in the diagram from the shell paper. Just to show this to you numerically, we found significant differences in forest canopy cover between A and, if you go from A to D zones, consistent with patterns found in other cities, reflecting a significant inequality in this key component of urban green infrastructure. Likewise, when you look at impervious surface cover, again, not as strong a difference, but you can see there's generally a little bit higher impervious surface cover in the D zones than in the A zones. And I'll point out that one of the reasons why this may not be as apparent is because Durham and this North Carolina in general, the cities tend to have a pretty high forest cover overall compared to many cities around the world. So that might be obscuring some of the differences, because when you see from above, you tend to get the forest canopy. We also obtained data on measurements of temperature done at the surface level. This is just a map of temperatures showing the variation across the city of Durham. And here's actually the data which was collected by citizens or scientists, using instruments and collecting on the street. These are at 6 to 7 a.m. temperatures during the month of July. And you can see that there are sharp differences in these temperatures, both direct temperature in Fahrenheit as well as the heat index, as you go from A to D zones. So if you live in D zones, you have lower forest cover, you have more impervious surface, you have greater effects of temperature. And in these times when everything is getting hotter and summers are becoming more unbearable for people, this has health consequences that we need to think about. In terms of birds, we conducted bird counts, GIN conducted bird counts in a number of parks. Because it's difficult to do these counts in places, in people's yards and so forth, we focused on parks within these different zones. And the results here are a bit more mixed. The different colors here are essentially the redlining categories. And you can see there are the number of species are kind of mixed up. So it's not a clear, consistent pattern. We found no significant differences in species richness or abundance between the A, B, or C, and D zones. So why did we not find differences unlike the study in Los Angeles? Durham is smaller, and given that birds move around, the small area might be obscuring differences. Durham also has fewer species than Los Angeles. That might also be having an effect on what we can capture. And of course, Los Angeles is more arid, so water availability and cost make a huge difference there, and that might be influencing it. But more importantly, I think in Durham, there have been some significant conservation efforts that have directly targeted offsetting the redline effects on birds. So Durham Parks and Recreation, which is the government department, as well as nonprofit groups like Keep Durham Beautiful and Trees Durham, have dedicated tree planting efforts across the city, taking socioeconomic status of neighborhoods into account. So they've put in more effort in the low-income minority areas for beautifying parks and planting more trees. Likewise, there are also these conservation areas or buffers along streams with efforts to remove invasive plants, plant more trees, things of this sort. And we suspect that this is what is kind of reducing some of the effect of redlining that we see in birds. So to conclude, we can say that yes, redline areas have significantly lower canopy cover and higher temperature and heat index than non-redlined areas, right? So there are clear implications in terms of inequality being reflected in the green infrastructure and amenities available to people. It also it doesn't affect bird species richness and abundance in the measures that we made, but we did find some differences in a few species that tend to occur in A, B versus C or D zones. But overall, I think a big message I want to share today is that when you have policies that are focused on equity and take into account these kinds of historical legacies of segregation or policies that resulted in social inequality, if you focus your policies on addressing those past imbalances, you can improve green infrastructure that can then begin to erase the legacy effects. But it requires collaborative efforts at all levels, from city government to non-governmental organizations to neighborhood communities. And I'm happy to talk more about that. So I'll stop with that, and I guess we'll take questions at the end of the webinar.
Thank you very much. So if anybody has got any questions, could they please use the Q&A box on your screen and put your question with your name and affiliation. Do we have a second speaker, Charlotte?
Yes, Marco is here.
Marco is here. Okay, let me then introduce our second speaker, and he can possibly get his slides sorted in the meantime. So yeah, so we got our second speaker, Dr. Marco Aurélio Franco. He's an assistant professor in the Department of Atmospheric Sciences at the University of Sao Paulo. He holds a PhD degree in physics from the same university. His research focusing on the atmospheric life cycle of aerosols, greenhouse gases, and their relationship to land use, with work spanning tropical forest and urban environment. He has conducted research at the Max Planck Institute of Chemistry in Germany and completed postdoctoral studies in collaboration with research centers for greenhouse innovation, applying statistical modeling and machine learning to atmospheric science. So welcome, Marco. So the floor is open for you to start your presentation. So let's try to keep it in 20 minutes. Thank you.
All right. Thank you very much, Prashant, and all the colleagues here. Can you hear me? I think it's fine, right?
Yep, very well.
Okay.
Yeah, thank you.
So actually, it's a pleasure for me to be here to just show a bit of what we have been doing here in São Paulo, mainly focused on our network, or our greenhouse gas network. I'm going to present some of the results of my master students, Jorge Piscoya Saltibanes. But also I'd like to introduce a bit of our Metropolitan network stations here. But first, I'd like to say a few things about how is the profile of greenhouse gases here in Brazil. If you see, the Brazil has a quite interesting characteristics of greenhouse gases emissions. So it's mainly focused on agriculture, energy, and land use change, mainly land use change, actually. But if you look for São Paulo, where we have our network here, the profile is quite different. It's mainly focused on energy, I mean, production of energy, biomass, burning, fossil fuel burnings, and so on, and residuals. It's mainly these two that are dominating the profiles here in São Paulo. So that's why it's important to have here a very good network of greenhouse gas monitoring stations to understand these emission profiles here. In fact, what my student has been doing is related to these 4 justifications for his project. The idea for us is to understand the role of vegetation in regulating the CO2 emissions here in São Paulo. Our stations, as I'm going to show you in a few minutes, we have different points measuring here, points with more urbanized regions, points with more vegetated regions, and so on. So we can at least try to compare, try to understand the dynamics of vegetation in regulating the CO2 emissions. Right, so our motivation is that understand the influence of vegetation in regulating the CO2 concentration in different regions of the metropolitan regions of São Paulo. And of course, to quantify the impact that vegetation cover has on carbon dioxide concentrations here. First of all, I'd like to quickly introduce you to our Metroclima network. This network has the main idea to assess the impact of greenhouse gases, and not only that, but also short-lived climate pollutants here in São Paulo. I think Prashant is already very well, he knows it very well. He already spent some time here in São Paulo with Professor Maria de Fátima. Maria de Fátima is the full professor here where I work, and she is the head of this Metropolitan project where I'm involved. So among other things, the project's main goals are mainly develop an integrated framework for measuring GHG and short-lived climate pollutants here in São Paulo. Of course, to establish a continuous monitoring network for GHG and air pollutants, evaluate how these emissions affect regional climate, assess the feedback of climate change on São Paulo's air quality, and of course, sharing these findings with governmental institutions and the public in order to have political actions in order to reduce pollutions and also to control the emissions of GHGs. Here are you can see where we have instruments measuring those components. Here IAG is where I work. It's the university I'm enrolled. ICESP and UNICID are regions with a lot of urbanization close by. I mean, IAG also has, but here in the university, we also have parks close by. We also have quite strong vegetation cover, which is very different from UNICID and ICESP. And Pico do Jaraguá is our nearly background station. It's located quite a bit far from the strong urbanization area of São Paulo, but still have some cities close by. But here it's mainly dominated by vegetation. Pico do Jaraguá is, I also need to highlight that it's a short mountain. Let's say it has about 1,500 meters high. It's not too high compared to other mountains, but it's quite high compared to where we are also measuring those other components here. Here are some information about these stations. My student is using data from all of these 4 stations to quantify the effects of CO2, the concentrations and the effects of vegetation on CO2. Here are some information about the altitude of these sites. Sorry, I said 1,500, but it's 1,000, almost 100 meters high. But yeah, here, and also the equipments we are using, mainly Picaros. And here, just quickly, a few characteristics of these stations. Here is the IAG where I work. As I told you, we have, of course, urbanization close by, but also a lot of vegetation as well. So it's a mixture of urbanization and parks and wood cover, vegetation cover. Here is Pico do Jaraguá, which is, as I told you, a short mountain close to the city, but it's mainly close to vegetation, parks. Here, actually, it's a reserve. In this place, you cannot build houses and so on. It's only for vegetation. Here are some characteristics of our stations there. Some instruments, we have Picarro, but also other monitors to measure those short-lived climate pollutants. Here is UNICID. UNICID is also a university here in São Paulo, but it's located in a very strong urbanized area. As you can see here in this video on the left side, you can see only just a few, unfortunately, just a few amounts of vegetation, a few amounts of trees nearby. In fact, the heat island here is very strong, as you can imagine, right? Unfortunately. And ICESP is our last site I'm going to discuss. Here we have just a few amounts of trees nearby, but the station is located at the top of this high building here. Here is the instruments located. So the nice thing about this station is that we can measure quite well the mixture in the atmosphere, not only the local emissions here, but let's say the well-mixed atmosphere here in São Paulo, and have a quite good understanding of how this urbanized region contributes to CO2 concentrations. Here are some characteristics of the land cover close to all these stations. Here, the stations are in the middle of this square. So it's a square of 5 by 5 kilometers squared. And as you can see, Pico do Jaraguá has about 60% of vegetation cover, while IAG AG has 23% of vegetation cover, ICESP 10%, and Uniseed, as you saw there, only 5% of vegetation cover. So it's we have this strong gradient of vegetation, which we are trying to understand, which we could use to understand the role of vegetation. Just a few data in order for you to show, for you to see what we have here. Now I'm focused only on CO2 concentration. Of course, we have much more data being collected, meteorological data, those short-lived climate pollutants. But as you can see here, my student is focused, he's only using data from 2019, 2020, up to 2022. It's because the other data from 2022 up to now, we do have them, but they are still being processed. So for a master's, I think he doesn't have too much time to do this processation, but for the PhD, for sure, we are going to use this data. Also, we have here in ICESP an isotopic measurement of CO2, so we can characterize, let's say, the age of these plumes and different other aspects, which is very interesting as well. But important to highlight again is that we have measurements up to now. We are measuring this continuously. Of course, we have some data gaps. So everybody here, I think, is kind of experimental. So you understand the difficulties we have in maintaining the measurements all the time. But in general, we have very good measurements being conducted in all these stations continuously. Here are just some characteristics, some statistical characteristics of those stations. Just averages in general, where we can see already that Uniseed and ICESP, they have the highest concentrations compared to Pico do Jaraguá and IAG. Pico do Jaraguá, as expected, has the lowest CO2 concentration, as we use also the site as a quite good, let's say, background site. Of course, it has the influence of air masses from the city and from other regions nearby, but it's the best site we have, at least for now, to compare the effects of traffic, of sources, different sources, and vegetation with the other stations. Just a few more statistics. I'm not going deep on this analysis because our time is quite short. But for a future talk, maybe I could dive deep into these things. But in general, we have consistently observed that Uniseed, that more strong urbanized region, has the highest CO2 levels in mostly of the seasons. Whereas Pico do Jaraguá has consistently the lowest CO2 levels across all the seasons. And regarding ICESP and IAG, changes depending on the season and, of course, depending on the sources and what's going on close to these sites. Just showing a bit, we are also conducting some statistical analysis focusing on the data distribution. It's a paper we are finishing right now, me and my students and I, and me. And we are actually using different statistics to characterize these distributions. I'm just going quite quick here because I'd like to focus on other data in a few minutes. But just to let you know that we are characterizing these differences regarding all the data, but regarding when these stations are measuring at the same time, simultaneously, so we can see how different those distributions are. And then try to understand the impacts of not only vegetation, but sources nearby on these concentrations. And what we are observing, I think it's nice, this figure here, is that indeed for all the seasons and all the cases, all the stations are quite different, indeed, as expected. So Pico do Jaraguá, our background station, is doesn't have a too broad CO2 concentration distributions compared to the other stations. It's quite constant, it's quite stable along the seasons and along the years compared to the other stations. And Unicid and ICESP, they have more variability since they are also in this metropolitan region. Also, it's important to highlight that IAG also have quite strong variability on the data, on the histograms, because mainly since it's a university, it has a strong flux of people, but mainly during the class semesters. But during the holidays, let's say, during the vacation, the university is quite empty. So there is not the CO2 concentrations, it drops a lot during these times, which what contributes to this strong variability of the data. But what I'd like to start actually going deep, it's about these daily and weekly cycles of the CO2 concentration. I think it's more interesting for us here and also for you to know our data, to know our station. And here you can see this CO2 concentration for summer, autumn, winter, and spring. Of course, during the middle of the day, because of the boundary layer evolution, the concentrations are less than during the night, where when the boundary layer traps these concentrations, the CO2 concentrations, and also the photosynthesis is not happening, of course. But we see consistently that Pico do Jaraguá, sorry that the legend is not here, but Pico do Jaraguá is the one that has the lowest concentration consistently. It's the blue one on all the stations. It's consistently the lower concentration, whereas, for instance, the red one is the IAG. The red one has a strong variability along all the seasons. But the interesting aspect here is that Unicid, which is this purple one, and ICESP, which is this green one, it's almost all the time with higher concentrations, not during the night or but during the daytime. Here you can see that ICESP has a shift compared to the other stations, a shift in the peak and a shift in the minimum concentration. And it's because this the equipment is installed at the top of that building. So it's feeling directly the evolution of the boundary layer. So when the boundary layer starts to evolve from the ground, it takes time to reach that height, which is about 100 meters high. So that's why we observe these shifts in the CO2 concentrations during the diurnal cycle. Here's some information about that. So indeed, Pico do Jaraguá has this lowest and most stable CO2 concentration across all the seasons. IAG and Unicid, they do have this strong diurnal variability with values peaking around 440 to 445 ppm, especially in winter here, when we don't have rains and we don't have this washing that could help a bit in removing these concentrations from the atmosphere. The concentrations are much higher, and also because biomass burning is close by. We do have strong biomass burnings that reach the São Paulo regions. The sources here, it's not only the traffic jam of the traffic in general, but biomass burnings from the region, from regions nearby. Here are some from some of these concentrations for the weeks. So we can see how it changes along the weekdays and also during the weekends. During the weekends, the concentrations are much lower, of course, much less traffic, and during the weeks, much more traffic. But here in São Paulo, for those who don't know, we have not all the cars can run every day. So let's say because of the number of your car, you can run 4 days a week. Let's say that's the idea. So this this variability in the traffic helps reducing the pollutions and reducing the CO2 emissions here in the city. But of course, there are some days in the week that we see stronger emissions as well. Here is just a comparison between weekdays for the diurnal cycle, between weekdays and weekends. Weekends, the concentrations in general are quite small compared to the weekdays has higher concentrations compared to the weekends. But for IAG, this red one, you see that during the nights, the concentrations is even higher, a bit higher compared to the weekdays. But in general, for the other stations, the concentrations are lower, and even the amplitude of this diurnal cycle, right? So it's because, of course, the source is close by. So in order to evaluate the effects, this is one of the approaches we are using. I'm just going to show you 2 approaches, but not in detail because of the time. But the first approach we are using to assess the effects of vegetation on CO2 concentrations is to look for the minimum in the boundary layer, I mean the maximum boundary layer, the minimum in concentration, and compare the sites for these periods. We selected winter and summer to assess these comparisons. We selected the period from 1 to 4 p.m. for all the sites. Then we could see indeed these effects of vegetation, let's say, disentangled from the effects of the boundary layer. Then we did that for summer and winter when we have more solar radiation and less solar radiation. And what we observed is that indeed Pico do Jaraguá also has the lowest amount, the lowest CO2 concentration compared to the other sites. And we are now going to use these values as background to subtract the average from the other sites and see the gaps on the concentrations. And this is what we have. Now we subtracted 412.6 ppm in summer and 415.8 ppm in winter from Pico do Jaraguá to the other sites, and we observed that IAG has these differences of about 2.1 to 2.7 ppm from summer to winter respectively, whereas ICESP 2.7 to 8.8 in winter, and Unicid 8.5 to 8.8 in winter also. So emphasizing here the likely effect of vegetation and of course on this concentration. So it's Unicid, the strongest site, the more strong urbanized site we have has the higher CO2 concentrations, followed by CESP and IAG, which is that site that I told you that has quite small urbanization compared to the other sites here. And other analysis we are doing are using the NDVI versus CO2. We are also trying to see the effects, actually the effects of this variation in NDVI along the months on the CO2. And here is some preliminary results we have so far, showing indeed that when we have higher NDVI, we have lower CO2 concentrations. I mean, the Pearson coefficient is not strong; it's quite weak, but those analyses are statistically significant, which shows that indeed, vegetation is acting somehow in regulating the CO2 concentration, but also it's important to highlight that we have a lot of traffic here, a lot of vehicles that plays, I would say, they play a much stronger role on regulating CO2 here in São Paulo. But vegetation is also very, very important, as we can see here. So, for instance, Pico do Jaraguá, we can see very well, and ICESP, those trains, whereas the other sites here, Unicid and IAG, we see quite small, much smaller percent coefficients, but still the trends are here quite evident. All right, so it's fast, but I'm really happy to be here to discuss our results, our data, our stations, and please feel free to contact me anytime for collaborations, for discussions. I'm really happy to be here. Thank you very much.
Thank you, Marco. This is very helpful. And thank you very much to Madhu as well for two fantastic presentations we have. So I'm going to pass it on to my colleague Rajan to chair the Q&A session.
All right. Thank you. Thank you, Prashant. And good morning, everybody from North Carolina. Yeah, I would like to also give a round of applause to amazing presentations. Thank you, both of you. So if anybody has more questions, please type your questions in Q&A, and I'm going to ask those questions to our two speakers. Let me start with Madhu. A question from Dr. Kumar is, what methods are used to quantify the bird biodiversity in your studies?
Yeah, in the interest of time, I sort of skipped over the method section, but I can quickly show a couple of slides that I already have that illustrate that. So essentially, we overlaid a grid on the city of Durham map, and used GIS approaches to compute the various environmental variables. For birds, we focused on parks and selected parks that are in the respective A, B, C, and D zones. And of course, the number of parks is limited, so we have relatively, that constrains the sample size. But what the method we used is what's called a point count. So Jinbai basically went to each point in these parks that were selected according to this scheme and stood at the site in the morning hours and counted all the birds that you see around you. And then he recorded that. He did that 3 times per sampling point during the breeding season and the non-breeding season. So this is in June of 2022 and December to February of 2022 to 23. And documented all the birds that you can see and hear and identify within a 10-minute count period within a 40-meter radius from each point.
All right, interesting. All right, let me go to Dr. Marco. I know your study is really amazing, looking at the greenhouse gas emissions and their spatio-temporal variation, and more comparative study looking at the from the different part of the cities, which is really amazing. And again, another question from Dr. Kumar. What is the most unusual trend you saw in your diurnal analysis?
The most unusual trend, right?
Yes.
It's actually from IAG, I would say, because I mean, it's a mixture of urbanized regions and parks, and it's hard to trace the sources, the CO2 sources there. We have vehicles, we have, of course, sometimes biomass burning reaching the site, but also the dynamics of the people using the university. So during the weekends, sometimes the university is used as parks. People come here to use the infrastructure. So also the CO2 concentration sometimes can be higher, for instance, during the summer. So I would say it's quite unusual, but also the ICESP diurnal cycle has a quite unusual diurnal cycle. It's mainly because of the instruments that are installed at the top of that building. So it needs, so I mean, it's measuring the evolution of the boundary layer delayed from the other sides. For me, at least, it's quite interesting in terms of dynamics, of micrometeorology dynamics, and it gives us actually a lot of ideas to explore for other students as well in the future.
Yeah, just to follow up on that, I think in one of your slides, you showed that the carbon dioxide concentration is different from one season to another season, right? The summer to winter. So uh, how much the species effect was that? Have you looked at for example, my understanding is in winter, most of the trees shed leaves, right? So there may be the less photosynthesis. So would that be also somewhat due to the different species effect?
You are right. The species, they do have a strong effect on this regulation, of course. But here in Brazil, at least here in São Paulo, the characteristics, the winter characteristics is not so strong as in North America or in Europe. So the trees here, they do not lose all the leaves. It's quite different. It's more like your autumn, I would say, more like the autumn. But indeed, the species, they change, they indeed affect a lot these concentrations. But here in São Paulo, it's mainly Mata Atlântica, it's the name of the forest nearby. So it doesn't change too much from region to region. But of course, for a deeper analysis, for a PhD analysis, for sure, we would like to go deeper in this regard. Thanks for the question.
Very good, very good. All right, let me get back to Madhu. And then I think it's more about like some implications and how cities are utilizing some of the research findings you've been doing. So our cities, the question from definitely from Charlotte. So our cities generally aware of the disparities in access to green spaces and its consequences. And are they doing anything to improve the situations? Are there any cities leading the way based on your experience?
Yeah, that's a great question. And I think as I sort of mentioned in the beginning of my talk, uh, even urban ecologists had not been really paying attention to these kinds of disparities until recently. So I think at some level, obviously, people living in cities and people involved in urban planning and policy are aware that there are disparities. But I think a lot of the research until the last few years has not really addressed these disparities in a way that can give input for policymakers and planners that's useful. So one example I can give is, for example, there's a lot of citizen science-based data collection in urban areas, and urban planners and policymakers have begun using that because it's easy. It's a good way to get data on, tree canopy cover or distribution of birds or things like that. But these are volunteer collected data. So there's a big program called eBird, right? Which it's an international program from the Cornell Lab of Ornithology. People go out and document birds everywhere. But what we found in this area in Raleigh, Durham, Chapel Hill, is that if you try to use eBird data to decide where to put your resources for green infrastructure or anything like that, you're not getting uniform coverage because people tend to go to places where they're likely to find birds, right? So these kinds of data have gaps in them or blind spots, which only make the disparities worse. So I think we need more systematic work to sort of highlight these things and provide results in ways that policymakers and planners can turn into actionable things. And that's kind of where my research is focused. There are cities, I would say that cities are becoming more aware of this. And of course, there have been more work on environment from the environmental justice perspective and more grassroots activism pushing for these kinds of things than from sort of an ecological research perspective. So we are trying to sort of bridge that gap and provide more research-informed sort of results for people to use in justifying and making more informed policies. And in terms of examples, I think Durham is actually doing pretty well, as I said at the end, that they have good programs working with citizen groups to make improvements. And there are some other examples in the US that are doing that as well.
Very good. I would like to ask a similar question to Marco.
Mhm.
How are your research findings being used or at least informed to the stakeholders like governments or policymakers? What sort of the mechanisms you have, kind of stakeholder engagements and inputs and things like that?
That's a great question. Actually, here for São Paulo, I'd like to first tackle the question for short-lived climate pollutants, and then I go for greenhouse gases. But for pollutants, atmospheric pollutants, we have here a company, a estatal company called CETESB. This CETESB is already from the state. They have very good stations, not only here in the city of São Paulo, but in the whole state of São Paulo. It has more than 70 stations measuring the air pollutants, and also not only the air, but also water and so on, soils. So they already have this direct contact with the government. So the government here in São Paulo, they already try to, of course, it's not so effective. It could be improved. It always can be improved, but it's they are already aware of the issues directly from CETESB. From our perspective as GHG networking measurements, we also try to keep them aware of these emissions, but it's not so easy, right? So we need to first maybe inform the university and then to inform other political persons that are involved with the governance here in Brazil, or at least here in São Paulo. So the difficulties are a bit higher, a bit bigger from the academia side, whereas from CETESB side, it's much easier.
Okay. Within a quick way, 1 minute, a question from Dr. Angela Allen. I know you both
We need to close, yeah, Rajan, very soon.
Yeah, 1 minute, like 30 seconds each. So what communities are you all working with? I know, Madhu, you touched a little bit. I know, Mark, also quickly on the communities.
So I work with volunteer. I have a citizen science bird count program. So we work with volunteers for that. We also worked with Tree Durham and the Durham Master Gardeners program. And we're trying to expand that to specific communities around the parks.
Thank you. Marco, quick 30 seconds. Are you engaged with the communities, local communities?
Yes, we do. We actually have local measurement with schools, with other actually houses in different neighborhoods here in São Paulo. So indeed, we are quite involved, but we are looking for more involvement with the other communities.
All right. Thank you. With the interest of time, once again, a big thank you to both speakers and those of you who asked the question. Thank you again. Back to.
Thank you very much.
So thank you very much from my side as well for being fantastic speaker, bringing in insight into these very interesting topics. And thank you, Rajan, for chairing this Q&A session so efficiently. Before I close, I would like to introduce you to the speakers of the next the webinar. So we have Charlotte Glazier. So she's the founder of the UK Pocket Parks. And so the pocket parks are something which has not been really explored much. So you can hear some interesting, the insights from the ground from Charlotte. And then we got another speaker, Dr. Daniel Green. He comes from Hertford University, and he will be talking about environmental monitoring and experimental data collection of nature-based solutions. So very different but interconnected talks. That would be on 15th of January in New Year, and that would be our webinar number 32. So if you are not a member of the network, you can still become a member. Just go on to the reclaim-network.org, and there is a form on the top. You can fill the form and become a member there. If you have any questions or queries, or you wanted to be a speaker on the webinar, just send us an email using that email written on your screen, info@reclaim-network.org. And if you are on Twitter, which is now X and LinkedIn, so you can follow us for the updates, which is coming from the network, offering a lot of opportunities in terms of secondments and workshops and the other fascinating things which is happening across the board. So you're most welcome to to attend them, to follow them basically. With that, again, I'd like to remind you on 30th of January, we are having our conference at Surrey. So we really welcome you all and like to see you as many as possible in person. Obviously, it might be a little bit of challenge for people overseas, but if you are around and you're planning something around that time, that would be fantastic to have you as part of the conference we will be having. So with that, I would like to thank everyone and see you in the next webinar.
Thank you very
Thank you.
much.
Yeah.
Bye.
Bye.